Hello students, today's topic is electric field lines. Okay, if you need, suppose here is a point charge. Now you want to, if you want to make the diagram of the electric field due to a point charge, how are you going to make it? Can we represent the field by means of picture? Then yes, we have a imaginary concept. Okay, this is completely imaginary concept. I'm repeating it. Field cannot be made, but we have made a concept, and we, in terms of picture, we can show the electric field, and that imaginary concept of electric field in terms of diagram, that is known as electric field lines or electric lines of force. Okay, then what are the conditions and what are the properties about that we are going to learn. Suppose here is a point charge again. Now the field lines, in order to make a field lines, first of all we have to imagine a test charge is present, the mouse. Again I'm repeating. Now in what direction the mouse will go, that will be the direction of the field lines. Like in this case, in what direction the mouse will go? The mouse will go along this direction, right? If you keep the mouse here, that is a test charge. In what direction it will go? It will go along this direction, repulsion. If you keep it over here, in what direction it go? It will go along this direction, right? So electric field lines, I have given you a note. It is the path. I repeat, it is the imaginary path. Imaginary path where who will move? The mouse. Test charge will move. Test charge would move, okay, if it is allowed to do so. All right, would move. Okay, so the definition of it you will find it. So what is the direction of electric field? The direction of electric field in this case is given by this direction. So we are knowing it. All right, then this is point number 1. All right, number 2. Now how to, as I have said, this is an imaginary path. This is a pictorial representation. Sometimes the field is strong, sometimes the field is weak. Now how to represent the strong field and the weaker field? Now, if the field lines are close, okay, if the field lines are close, it means electric field is strong. Okay, like suppose I have made a tooth picture. The field lines are like this, let's say. Okay, now I have made two regions. Let's say this is region number 1 and let's say this is region number 2. All right, now where the electric field is strong, then we can say this one, because the magnitude of field lines, okay, is given by the closeness, okay, the closeness of the field lines. So here the fields are closer, that means the the electric field is strong. Here the fields are weaker, as the fields are far away, that means field is weak over here. Here also one thing, you see, as I'm making the fields, right, lines, they are diverging. It means what? As it go away, the field gets weaker. Okay, now can we know how much exactly is the value of electric field from the field lines? The answer is no. The answer is completely no. Okay, we cannot know. Like suppose I say it is a matter of subjective. Like suppose I will make it now for the point number 3. One by one we have to do it. Suppose here is plus q. Okay, here is, there are two students. One is making the field lines of plus q, another is making the field lines of that same plus q. This is quite active. Let's say this is lazy. Okay, now if this boy is making 4 field lines, you can see the fields have to go outward because the test charge is moving away, right? And if this student wants to make 6, he can do so. There is no objection. Okay, so it is a matter of subject. However, now suppose if this near to plus q, here is also minus q. Alright, for plus q, if you are using 4 field lines, then for minus q, you should use 4 field lines. It's a matter of your choice. There is no such hard and fast rule that for this charge, this many field lines. But if you are choosing 1 as a standard, in this case 4 have been chosen as a standard, so you have to stick up with this, even in this case. Now, in this case, how the field line should go? Positive test charge, imagine how many it should go. It should go this one. Okay. In this case also, if for this student, minus 4 minus q, how many field lines have to be there? There have to be 5 field lines. Okay, going inward. Okay, clear? Now, again, I'll stick to it. If this plus q, if here it is 2q, just double it of it, then how many field lines there have to be? There have to be 8 field lines. You can't change it. Once you have chosen the standard, with the standard you have to move along. Okay, so it's a matter of the subject, it's a matter of your choice. However, it should have the objective which you can't change it. Okay, I have given properly there in the notes, so please go through that. Okay, now related to that, we can do some questions also, like here it is, suppose here is 4 field lines q, and suppose here is 2, then here it need to be how many? Here need to be, suppose it is 2q, then how many there need to be? There have to be 8 field lines, right? Then what should be the ratio of, okay, nothing have been mentioned. Okay, let's say just charges, only this much have been mentioned. Then what should be the ratio? Ratio of, let's say, 1:2. What is the ratio of 1:2? Then can we say, yes, there is 4. How many field lines? There is 8. So 1:2, right? That means whatever the charge here, the other have to be double of it. So we can get numerical based on that. Okay, so there is one. Another, okay, direction. All right, suppose I'll get an example. I'm making the field lines. Let's say we are not all the time, we can't stick up with the point charge, so I'm just making in general the electric field lines. Okay, now at individual point, if we draw straight line gives the direction. At individual point, if we make the straight line, then that straight line would give the direction of electric field at that point. Okay, all right. So at this point, what is the direction of electric field? Direction of electric field is given by the tangent to that point. Okay, so that is one of the application of the field lines. Okay, similarly, at this point also we can consider what is the direction of electric field. This is along here, straight line, right? So this is the direction of electric field. Though we cannot say anything about the magnitude of the electric field, however, we can say about the direction of the electric field. So it's always, so what? The tangent, what the tangent does, it gives the direction of the electric field. Okay, now another. Then there are so many properties, like 2 field lines can't intersect with each other. You will see that in the board, so many questions comes, because at this point, if the two field lines intersect, means what? At this point, what is the direction of electric field? At this point, what is the direction of electric field? This same point, having two directions of electric field, impossible. So can't intersect with each other. Okay, so field lines can't intersect. Remember this, intersect. So there are some rules which you need to follow about making the field lines. So about that I'm telling you about this. Okay, then what else? Okay, now how to represent uniform field? Okay, equally separated parallel lines, equidistance parallel lines represents what? It represents uniform electric field. We need to remember. So whenever you will see parallel equidistance lines, it means what? Uniform field. Now what is the direction of electric field at this point? Along the tangent, right? That means what? In this direction the test charge would move, right? Okay, then so uniform, this is what it is, parallel for the this is for uniform field, isn't it? This is point number 6. Uniform field is represented by equidistance parallel lines. Then point number 7, okay, through any body, suppose this body is a charged body due to whatever means, okay, then the charged body will create the field of its own, right? Now how we are going to represent the field lines in terms of picture? Then always the field should be 90 degree to the surface. Very important. In the next 2 chapters we are going to discuss about this. So point number 7 would be what? Point number 7 would be, what to say, E have to be perpendicular to the surface. Okay, students, remember it. All right, then more or less tangent E is always perpendicular to the surface. Then one more I have given, that I'll discuss it later, that inside the conductor electric field is 0. This is only in the case of conductor. I'll not talk about this. In the capacitor chapter we are going to discuss, however this is related. So electric field inside the conductor is 0, means what? No field lines inside the conductor. Okay, suppose in this region, if electric field is 0, will there be field lines? No, there will not be field lines, because the test charge will not move under, as it is not having any effect. Okay, fine. All right, now of all the points what I have suggested here, okay, can we make the field lines? Let's say the question is, make the field lines. Okay, make the field lines. Fine, field lines. All right, suppose here is plus q and here is, let's say, minus 2q. Okay, now whatever the field it has, it need to have the double of it, right? Now wait a moment. So how many are we going to choose? It's a matter of subject, as we have said. Okay, let us stick with let's stick with 4. So if I'm sticking with 4, then here it need to be how many? It need to be 8, right? Now test charge would go in what direction? The test charge will be repelled by q, while it will be attracted by, what to say, this. So how the field lines will be? I'm going to make 4 for q. 1, it will go, right? Then 2, right? 3, right? Then 4, right? Okay, now how many fields should come to here? It need to have 8, right? But it cannot go up to here, because the next